Hey guys, welcome back to my channel, and today we're going to be talking about two more derivative rules that we haven't covered in the previous video over derivatives. So you can go check that out as well. I've covered basically 5, so now I'm going to talk about 2 more. One of them is going to be the chain rule. So chain rule is actually one of the easiest ones, but it just looks hard when you look at it. But the formula I'm going to write down first. So if I'm taking the derivative of a function, so I'm going to write f prime of x because that's a notation for derivative, equals f prime, and then let's say there's a function in here, g of x. So basically chain rule involves two different functions, times g prime of x. So basically how chain rule works is, think about an M&M. You first eat the outer layer, then you eat the inner layer, right? First the colored part, then the chocolate inside. In the same way, this is how chain rule works. You first do the outer part, and then you do the inner part. So let's say I give you an example. Let's say I have square root x squared plus 1. So this is an example that we're going to go over, but before we do that, I want to tell you something that we involve usually with chain rule. A lot of the problems you're going to see is you're going to have a function like this, like g of x raised to the power of n. And the way chain rule works is you combine the power rule and the chain rule. So first the outer part. So g of x is inside this n. So you first have to do the n. So for the n, you just use the normal power rule. So it'd be n g of x, because you have to do first the outer part. You take the derivative of first the outer part, and to take the derivative is just n, and then n minus 1 here. And then you take the derivative of the inside part, which is g prime of x. So that is the power rule combined with the chain rule, which most of the problems you're going to see are going to be like this. So it's important to know this. So I'm going to just erase this, and then we're going to just start. I'm just going to tell you the problem again. So it's x squared plus 1. So if you have a problem with squares, cubes, stuff like that, the best way is to write it in terms of a power, because that's the quickest way. So here, obviously, this is x squared plus 1 raised to a half. So now I've written it as a power, which makes it a lot easier. So we do the outer part first, which is the power. So it would be 1/2 on the outside. And then remember, the inner is still going to stay the same. We haven't come to the chocolate part. Okay, and then we have to do n minus 1. So this is the n minus 1, and 1/2 minus 1 is negative a half. And then we did the outer part. Now we're going to do the inside part. So the inside part is this chocolate part, x squared plus 1. And to do this, it's just the normal derivative rules. X squared, we use the power rule, which is 2x, and a constant always becomes 0, so we're just left with 2x. And then just for sake's being, I'm going to write this more nicely, so that way we can get our final answer. So we get 2x over 2, and then the square root of x squared plus 1 goes on the bottom because it is a negative 1/2 and not a positive. And then we can obviously cancel out the 2, so you're actually left with x over x squared plus 1. X over square root x squared plus 1. Alright, now I want to do another problem with you guys so you guys have an idea of how this works. Same thing. So this one's actually a little bit nicer to you. X squared plus x plus 1 to the negative 1/3. And this one already gives you the power, so we just do outer minus inner. So the outer is the power, so it's negative 1/3. Remember, you don't do the chocolate part yet, so this is just going to be x squared plus x plus 1. And then we do negative 1/3 minus 1 because it's n minus 1. And that gives us negative 4/3 because basically it's just negative 1 over 3 minus 3 over 3, which is negative 4 over 3. Now we do the inside chocolate part, which is 2x for the first part. We do this derivative, and then this derivative, and x is just plus 1 because that's the slope, and this becomes 0, so it'd just be this. So that would be your final derivative answer. Right? Now another one we're going to talk about for derivatives is logs. So there are 3 rules I want to refer to. So number 1 for logs, let's save. So here's another notation you'll commonly see for derivatives as we talked about, d over dx. So that's the way I'm going to write these 3. So log and a base of b and x. So let's say you given this type of situation asks you to find the derivative of this. It's basically just 1 over ln, the ln of b, which is this b base. You just write ln and then whatever this value is. So if this was 2, you just write ln 2. And then you have the x, so whatever this is. So this could have been x squared, this could have been x squared plus 1, anything here. This could have been anything. You just put that there. and then you multiply it by the derivative of x. So let's say this was 2x per se, right? Let's pretend this was 2x. Then the 2x would go here, and then the derivative of 2x would go here. All right? The second formula for this is d over dx, okay, b of x. So we are given b, and then we're raising it to a power of x. So if we have a situation where we have a value b, which is just a value, not just a number, a number to a power of x, it's just b of x. It's kind of like e to the u times u prime. It's the same way as b to the x times x prime, except this is a base, so therefore you'd have to still multiply by ln of b. And then the third one be d over dx ln x. So we're given an ln, and then we're given an x, which can be any function x. And then this is just 1 over x times x prime. X prime means the derivative of x right here. So now let's say this one, there's also another version of this. Let's say it was ln absolute value of x. It would be the same thing. It would be 1 over x times x prime. So this and this would still be this formula. All right, so make sure you remember these 3 formulas. They're very important. You're going to need to remember those because you're not going to be given a formula chart most of the time. So now I'm going to go over a problem from each of these 3 so you have an understanding of how it is. So I'm going to start with 1. So ln x cubed plus 1. So remember, the formula was 1 over x times x prime. So that's what we're going to do. It's 1 over, this is the x here technically. So it's x cubed plus 1 times x prime. And this is the x, so the prime of that is just, or the derivative of that is 3x squared because the constant goes to 0. So that would be our final answer right here. Okay? The next one is 2 to the 3x. It asks you to find the derivative of this. Remember, you first leave it the same. Then you multiply by the derivative of this, which is 3. And then you also need to have an ln, so it'd be ln of this base 2. So it'd be 3 ln, so the best way to write this is write this first, so 3 ln 2, and then 2 to the 3x. Okay? Lastly, we have one more problem. We have the log one. So log of base 4, 5 minus 2x. Okay? Remember for log, it was just 1 over x first on the bottom, and then we also had the ln here, so it was ln of 4, and then remember it was x prime, and this is the x, so you had to take the derivative of that, which is negative 2, so this would be your final answer multiplied by. Alright, so thanks for watching. Please look over these formulas, really helpful, and if you have any questions, please put them down below, and thank you so much.